Okay, we're on Unit 9, Lesson 9, Mixed Practice with Fractions. We're going to review some of the inverse relationships between multiplication and division in fractional amounts, so that should kind of be review for you. And we'll divide fractions or mixed numbers by other fractions. You can use the number line to help you with that or pictures. So as we go through, you'll need SAB page 389 to 390. Okay, so let's just start with add, subtract, compare, and multiplying fractions. If you look at this fraction box that's up here to the right, it just shows you the same two fractions as they're compared, added, subtracted. So when we look at this, you should notice the first section, it compares them. When we say compare in math, we're talking about that greater than and less than symbol. So greater than, less than, we're comparing. When we compare 3/6 to 1/6, you should notice that you find the common denominator, and then that really allows you to compare. So that's the strategy to use there. Versus when we're adding and subtracting, right, which is this green highlighted section here, you still need to find that common denominator. Think about how when you find that common denominator, that works, and then you are allowed to add and subtract those equations. Okay, same with subtraction, as I said, adding and subtracting, find that common denominator and you can simply add and subtract. That's totally different than multiplication. Multiplication, right, you just multiply straight across. So my pink bar here, you're really just going to multiply straight across. No worries about common denominators, right? Multiply 1 times 1, 3 times 3. So we're going to try that and practice that here on these next few. First, we're going to compare. So in order to compare 2/5 and 7/10, I need to find a common denominator. Okay, I should notice right away that my common denominator for these is going to be 10. So I know that whatever I do to the denominator, got to do to the numerator. I'm going to multiply times 2 in order to get fifths to tenths. I should find that I get 4/10. Okay, and now that I've got 4/10, I can compare 4/10 to 7/10, right? So as I go through and compare those, I should see that 4/10 is greater than, or 7/10 is greater than 4/10. Much like over here, right, my common denominator is 35. Whatever I do to the denominator, I got to do to the numerator, and I can find that 3/5 is the same as 21/35, and 4/7 is the same thing as 20/35, and then I can actually compare them better. When we add, I need this common denominator, so now I'm going to take 4/10 plus 7/10, 4/10 plus 7/10, right, guys? 4 plus 7. You don't add the denominators. Okay, much like over here, I'm going to take 21/35 plus 20/35. Okay, and so you guys can see how those work out. I get an improper fraction when I do that. That improper fraction that then needs to get converted into a mixed number. So hopefully, as you guys were thinking, you're like, well, 4 plus 7, that gets me the 11/10. 20 plus 21, that gets me 41. And then I need to convert it to that mixed number, which is that next number over. So ultimately, because you guys are in 5th grade, you need to get to this green number, right? You need to get to that mixed number. When we subtract, same thing, right? So I'm going to take 7/10 and I'm going to subtract 4/10 from it. So 7 minus 4, because I already have my common denominator. When I take 7 and I subtract 4 from it, right? And then on the other one, I'm going to do 21 and subtract 20 from it. So I get 3/10 respectively, 1/35. Okay. When I multiply, I don't need to use a common denominator. So I'm going to go back to those original fractions. And I'm going to think, okay, well, what is 2/5 times 7/10? Before I do 2/5 times 7/10, I could actually simplify. So it would look like this if I simplify before. I'm going to take 2 times 7 over 5 times 10. 2 and 10 have something in common, so I'm going to reduce those down. 2 is a 1. 2 goes into 10 5 times. Okay, so I just simplify before I go ahead and multiply. 1 times 7 is 7. 5 times 5 is 25. So I get 7/25, right? I'm going to go ahead and then just multiply straight across on this next one. So it would be 3/5 times 4/7, 3 times 4, 12, and 5 times 7 is 35. Okay, so respectively. All right, So how are adding and subtracting and comparing fractions alike? Well, notice that when we add, subtract, and compare, you have to find the common denominator. Versus when you multiply, there's no common denominator. You don't need that. You just multiply straight across. Okay? So now we've got to answer a puzzled penguin question. Dear math students, one of my friends said that he would give half of his sandwich to me and half of his sandwich to my sister. My sister said, but then you won't have any for yourself. This doesn't make sense to me. I know that half plus half is 2/4. My friend should have plenty left over for himself. Did I do something wrong? What do you think? So tell Puzzled Penguin what he did wrong. What's 1/2 plus 1/2? Write out your answer. Okay, you need to come with that Puzzled Penguin question answered and be prepared to talk about it. Remember what the trick is with addition. If you're not sure what the trick is with addition here, come back up and reread up here. Okay? Okay, so let's go on and apply some of what we know in word products and story problems. Yesterday, Mr. Swinson made 2 3/4 quarts of strawberry jam and 1 1/8 quart of raspberry jam. How much more strawberry jam did he make than raspberry jam? So you're going to take 2 3/4 and you're going to subtract out 1 1/8. Okay, when we subtract, we need to find common denominators, so I need to switch this fraction to 8. So I'm going to multiply by 2 because I know that if I multiply by 2, then I can get myself 8s. And I still have an equivalent fraction. So 6/8 minus 1/8, 5/8. 2 minus 1 is 1. So 1 5/8 quarts difference. All right. Today, Mr. Swinson is making 2/5 a quart of grape jelly. He's going to give half of that amount to his neighbor. How much will he give? Okay, so I'm going to take, this is a multiplication one, I'm going to take 2/5, multiply that, because he's giving 2/5 of, right? Look for those keywords. This is my keyword right here, of, 2/5 of. It tells me I'm going to multiply. So I'm going to take 2/5, multiply that by 1/2. Okay. These actually cross each other out when I think about multiplying, and I get 1/5. Okay, I'm going to show you if I just multiplied straight across, right? I would get 2 over 10, which is equal to 1/5. So hopefully that makes sense to you. Mr. Swinson is also making 2 1/6 quarts of cherry jelly and 3 1/12 quarts of orange jelly. He's going to mix the two kinds together to get orange cherry. Interesting. How much of this mixed jelly will he have? So you're adding this time. So when you add, remember you're going to go 2 1/6 plus 3 1/12. Find that common denominator by multiplying 6 times 2, 1 times 2, which gives me 2/12. So now I can add 2/12 plus 1/12, which is 3/12, and 2 plus 3 is 5. So he's going to have 5 3/12. Hopefully you noticed right away 3/12. I can simplify that or reduce it 1/4. Okay, so 5 1/4. Okay, simplify it out. Yesterday, Mr. Swanson made 7/10 of a quart of blueberry jam. His family ate 1/10 of it. Okay, again, that word, keyword is of it. How much jam is left? Okay, so this is a multi-step problem. How much jam is left? Then we're going to find out how much they ate. They had 7/10 and they ate 1/10 of it. So 7/20. Okay, how much is left then? Well, 7/20. We gotta, oops, I multiplied wrong. I added there. Let me erase, guys. Sure. They didn't have left 7/100 of it. They had left the leftover portion of it, so 63/100. Does that make sense? Okay, let's go on. Suppose that Mr. Swinson has a jar that holds 5/6 of a quart, jars that hold 3/4 of a quart, and jars that hold 2/3 of a quart. Which size holds the most, the least, and how do you know? So find common denominator and compare them out. Pause the video, come back and check. Okay, welcome back. Here's what you guys should have found. 5 quarts is the most, 2 quarts is the least, and here's how you know when you look at common denominators. All right, we'll see you guys in class tomorrow.